All right, so 15.3 factoring ax squared plus bx plus c, which is nothing more than a quadratic. The thing that we're going to focus on, though, is this number a. Remember last time we did it when a was equal to 1. Well, now a is going to be anything but 1. Essential question of the day. How can you factor expressions of the format ax? That is a quadratic. Quadratic because it has the highest power of what? 2. Beautiful. When a is not equal to 1, examine factor pairs for a and c and determine which arrangement of factor pairs produces b. We're going to do it by what? Grouping. Okay? So let's get to it. Okay, so vocab. Factor by grouping. Okay, so let's say that I had 20x squared plus 10x minus 3, 3, let's just say x plus 9. Okay, actually, let me think about this because this actually has to be, I'm a reverse engineer it so I can make sure that I get this right. So I know that if I multiply this out, I can take a 10 out. So if I take a 10 out, I am going to get what? I could take a 10x out. I'm going to get a 2x plus 1. Then if I want that, let's say 3. So I'm going to put a minus 6x minus 3 there. Okay, so that makes sense to me right there. So if this was your original equation and I want to do this, I'm going to group these first two and I'm going to what? Add them. Now, I just showed you my hand because I sat there and I reverse engineered this, okay? So what would you do? You would take 20x squared plus 10x. And I told you, find the GCF of what? The numbers first. So I'm going to find the GCF of 20 and 10. Well, I would break down the factors. I would get all the factors down, or I can just look at it because math-wise, I know 10 goes into 10. I also know 10 goes evenly into 20. So 10 for the numbers is my GCF. Now I look at the what? Variables. So I have x squared, I have x to the first. Which one is the smallest power? 1. That means there's at least one x over in this bigger power, right? So 10x is my GCF for this whole thing. So what do I do with that? You got it. Use the parentheses, right? Put this in parentheses. Remember, copy the parentheses. What do I put outside of the parentheses? The GCF, which is 10x. And then I divide each term by the GCF. So 10x, 10x. So 20 divided by 10 is what? 2. X squared divided by x to the first. I subtract. 2 minus 1. 2 minus 1 is 1, so I get x. Bring down the plus sign. 10 divided by 10 is 1. X divided by x is 1. So I get 10x times x plus 1. And you can see I wrote that right there. We're going to add that to, let's do this one now. Negative 6x minus 3. I look at the numbers, 6 and 3. What is the GCF of the numbers? Well, I know 3 goes into 3 and I know 3 goes into 6. So I know that my GCF for the numbers is 3. Okay, so that is the GCF of the numbers. Then I look at the variables. Well, I have an x here. I don't have an x here. So my GCF is just plain 3. So what do? Put this in parentheses, copy parentheses down here, put my GCF outside, okay? Now, this is a positive 2. So in order to get that positive 2, I'm going to bring out the negative 3. So here we go. Divide each term by negative 3. So here we go. Negative 6 divided by negative 3 is a positive 2. Okay. X divided by nothing, I get x. Negative and a negative is a what? Positive. So 3 divided by 3 is what? 1. So if I do the second one, I get this plus. Now write it just how you see it. Negative 3, 2x plus 1. Now, I know you're sitting there going, hey, what is this plus minus stuff? Well, a positive 1 times negative 3 is really what? Negative 3. Okay? So don't be confused by that. So I'm going to write that right now. So I get 10x, 2x plus 1. A positive 1 times negative 3 is just negative 3. 2x plus 1. Okay? Good there. Because you got to make sure that you're keeping all the signs where they need to be. But now, how many terms do I have? Yep, I have 2. And is there anything exactly alike in both? Yes. So I know greatest common factor. Get it? Greatest common. It's common in both. So the common factor is what? 2x plus 1. So what can I do with that? You got it. Put this in parentheses. Bring down your parentheses. Put what outside of it to the left? Your GCF. 2x plus 1. Now what do? Divide each term by the what? GCF. Divide each term by the GCF. Notice every time I always leave space between the parentheses because I know I'm going to divide. So we know that 2x plus 1 divided by 2x plus 1 gets me 1. What's left? 10x. 2x plus 1 divided by 2x plus 1 is 1. What's left? Negative 3. So my final answer are these two binomials. 2x plus 1 times 10x minus 3. Okay. What about simplifying a quadratic? Well, remember the first rule that we always have out of the 4 steps is always simplifying. So what if I gave you 4x squared minus 10x plus 8? Immediately you should see what? That there are all even coefficients in a constant. So what is the greatest common factor of 3 numbers? 4, 10, and 8. Well, I know this is 2 and 2. I know this is 2 and 5. I know this is what? 2, which this gets me 4, so 2. So 2, 2, and 2. What is something that goes into both? Here's a 2, here's a 2, and here's a 2. So I know at least 2 goes into all of them. So again, here we go. Put it in parentheses. Put your parentheses. My greatest common factor goes outside of it. Okay. Divide each term by what? The greatest common factor. And what do you get? 4 divided by 2 is 2. So I get 2x squared. Minus 10 divided by 2 is 5x. 8 divided by 2 is 4. So now you have a simpler quadratic here. Take out the unnecessary 2 that's in there so your numbers don't get big. And there's a reason why we want to always simplify. It will make your life easier in the end. So let's say that I have 15x squared minus 5x plus 30. Well, obviously I can look at all 3 terms and I see a 5 will come out. So my greatest common factor is 5. Notice I'm using these parentheses. I'm going to divide each term by what? 5. So 15 divided by 5 is what? 3x squared. 5 divided by 5 is just 1. So I get negative x plus what? 6. I have something a lot easier to deal with. All right, so factoring a quadratic when a is greater than 1. Last time we talked about when a is 1, it was pretty simple, okay? This process is going to take the process that we already learned, except for we got to do an extra like 2 or 3 steps, okay? So here we go. Let's take something very simple as, let's say that x squared, because the last one I showed you was x squared plus 6x plus 8. Now, I'm going to show you ahead of time what I'm going to do. I'm going to multiply everything by 2. Okay? So my new problem gets what? 2x squared plus 12x plus 16. So let's say that we started there. We already know the answer to the original one. But now, let's say that I have 2x squared plus 12x plus 16. What should you do first? That is correct. You should find the GCF of 2, 12, and 16, which we already see. What is the GCF going to be? 2. So now, if I have a 2, put this in parentheses, make your set of parentheses, put the what? GCF outside, divide each term by what? 2. Okay? So I get 2 divided by 2, so that's 1, so I get x squared plus 6x plus 8. And now I can factor the quadratic that's on the inside, leaving the 2 on the outside, makes my life a whole lot easier. But that's just one way. This is still when a is equal to 1. We know how to do that. So let's do another example where a is not 1. Simplify quadratic. Okay, so I have 2 examples here. All right, this 12x squared plus 62 plus 70, and I have a 3x squared plus 11x plus 6. What I'm going to do is work the process all the way down, step by step, using those 2 examples, so I won't switch up the examples through this tutorial. I want to make sure that you understand it completely, but I gave 2 different examples to do 2 different things. So simplify the quadratic, okay? Now, I immediately want to be able to look where? At the coefficients and the constant. I see that all of these are even. So you immediately have to figure out, see if one of them goes into everything. Does 12 go into 62? Well, let's look at it. How would I get another 2? 12 times 6, well, no, it doesn't go in evenly. So immediately, I'm just going to do a factor tree. So 2 and what? 6, 2 and 3. Makes my life easy. 62. 2 and what? 31. See, that cut down a whole lot of guesswork because of that 62. There's only a 2 there. And I know that 70 is even. I don't even have to do the factor tree all the way down. I'm going to do it because with 2 going into 62 only 31 times, 31 is prime. I know that 2 is going to be in all 3 sets. 31 is not going to be anywhere for 70, okay? But I'm going to do it. 2 times what? That is 3. That's a 10, so 35. So I get 5 and what? 7. So here's a 2, here's a 2, here's a 2. So I know a GCF of 2 can come out, okay? So what do? Put it all in parentheses, put my parentheses, put the GCF outside, and now I do what? Divide each term by 2. That's how simple that is, okay? So 12 divided by 2 is what? 6. Keep the x squared. 62 divided by 2 is 30 what? 1. So x. 70 divided by 2 is what? 35. You've already done all the work, okay? So that's how simple it is to simplify this one quadratic. Okay, so we're dealing with quadratics that what? A is greater than 1. Okay, so what's the next step that we have to do? We have to list A, B, and C. Now remember, this 2 is multiplied by everything. You can't get rid of it. But I'm only going to deal with the terms that are inside of the parentheses because that's where my quadratic is. So what is A? A is equal to what? 6. B is equal to 31. C is equal to what? 35. This is going to be important because this is positive, this is positive, this is positive. And I've already explained that you can figure out your answers pretty much because we have to know when C is what? Positive or negative. And we need to know B when B is positive or negative. So we had this little graphic organizer that made my life easy. I knew that if C was positive and B was positive, my answer was going to be positive, positive. I knew that if C was positive and B was negative, I was going to get negative, negative. Okay. I also knew that if C was negative and B was positive, then C would be negative times a positive with the bigger number being positive. Okay. And then if C is negative and B is negative, then that means that I'm going to multiply by a positive, but the negative number was the bigger of the two. Okay, so that's our little graphic organizer that we need to have, and I'm able to figure out what A, B, and C is quickly. Multiplying the absolute value of A times C, okay? So this is the next step that we have to do. We already figured out what A was for the first example, B, and C, okay? So what are we going to do? We are going to take the absolute value of A and multiply it times the absolute value of C. So A is 6, B is 35. With that being said, I take those and I multiply them together. Now, if you don't know it, just put it over there. 35 times 6, that gets me 30. Carry the 3. 6 times 8, 6 times 3 is 18, plus the 3 is 21. So I get 210 is the new factor number, the number I want to factor. So where do we start? That's correct. Start with 1. Always, always, always start with 1. So 1 times what? 210. Work to the next number. 2. 2 times what? Well, 2 goes into 2 one time. Doesn't go into 1, but it does go into 10. So 105. Does 3 go in? Yes. How do I know? 2 plus 1 is 3. If you added the digits, it lets you know. So 3 goes into 3. So I get 3 goes into 21. How many times? 7. Doesn't go into 0. So 70. Does 4 go in? No. Does 5 go in? Yes. 5 goes in 4 times. That's 20, so that's 10. So 42 times. Does 6 go in? Well, you might have to check it. So 6. Here's 210. Let's put 3. So I get my 18. That is what? 3? 30. Oh, look at that. 6 will go in. So goes in 3 times. As you can see, 30. So it's 35. Simply put, does 7 go in? Yes. So I get 3 and 0. 7 goes in 30 times. Notice I'm just working my way down as I go. Does 8 go in? Well, check it. Here's 8. Here's 210. Let's put 2 because that's 16. So that's 50. 8 doesn't go into 50 evenly. So no, 8 doesn't go in. What about 9? So since 9 is a product of 3, it might. So let's put 2. So I get what? 2 times that, that's 18. What I get? 30. 9 doesn't go into 30 evenly. Okay, what about 10? Well, we know 10 is going to go in. How many times? 21 times. So now I got to work through 11. 11 won't go in. 12. No. 13. No. 14. No. 15. Let's check 15. So if I check 15, I get 210 right there. It would only go in one, so that's 15. 21 minus 15 is 60. So if I did that, that would be 404. So it goes in 14 times. So that means that 14 would have went in. So I would have 14, 15 over here. Does that make sense? Okay. And I'm done because here's 14, here's 15. That's all of the factors. Sometimes you will get numbers like that and you have to make sure that you're able to factor it. Okay. So add and subtract factors to equal b. Okay, so here are all the factors that we found. 210, yes, it's a big number. So what am I going to do? I'm going to put these equal signs right here for every set of factors that I have. And now, what do I have to take into consideration? Well, C was what? Positive. B was also what? Positive. So that means all of these factors are what? Positive numbers. Okay. Since they are all positive numbers, I need to look at them as addition. Now, what is B equal to? Well, B is equal to 31, or positive 31. So let's just add these up, okay? 1 plus 210 is what? 211. 2 plus 105 is 107. 3 and 70 is 73. 42 and 5 is 47. 6 and 35 is what? 43. Okay. 7 and 30 is what? 37. 10 and 21 is 31. 14 and 5 is what? 29. So which one works? You guessed it. The 10 and the 21 are going to be my winning factors. Rewrite the quadratic with new factors. So again, a is greater than 1, and this is the reason, this is the new step. This is the step that we have to do that's a little bit different than if a was just equal to 1, okay? So remember, we started with 2 times the quantity, 6x squared plus 31x plus 35. And then we found the absolute value of a times c, correct? So 10 times 21 was 210. Then we found that the factors 10 and 21 are equal to 31. See how that works? 10 times 21 is 210, which is equal to 6 times 35. Okay, and that's how we got 210. That is 6 times 35. So that's how we got 210. And the factors 2 times 21 gets me there. And 10 plus 21 is equal to 31, which is also B. Does that make sense? So now let's rewrite this quadratic that's in the parentheses. So I get 2, bring down the 6x squared. Now instead of writing 31, I am going to split this 31x into 2 different parts using the 2 factors that I found to equal 31. So I'm going to write 10x, not squared, 10x, okay? And then 21 plus 21x. 10x plus 21x is what? 31x. So I haven't really changed anything. Plus 35. So you go from a trinomial to what? A polynomial with how many terms? 4. Okay? And you need to do that so you can do grouping on the next term. Factor by grouping. So we're almost there. Okay? We're almost there. I'm able, now that I have this all split up, group what's inside the parentheses. Now, the 2 doesn't disappear. I'm just going to leave it alone for a little bit. I'll bring it back at the end. So here we go. I have 6x squared plus 10x. I'm going to put that together. Plus 21x plus 35. Okay, so I grouped it. I just put them in two binomials. I'm still adding them, okay? And now I deal with them individually. So I want to find the GCF of what? The constants. The coefficients. So 6 and the 10. Does 6 go into 10? No. But I know that the factors of 6 are what? Just 2 and 3. I know the factors of 10 are 2 and 5. I have a 2 and a 2. So I know my GCF is going to be 2. But now I look at my variables. I have an x squared and I have an x. What's the smallest power? 1. So I know there's at least 1 in the other one that's bigger. So my final GCF is 2x. Now I told you to do what? Always put parentheses around your binomial. Drop down, make a blank set of parentheses. Put your GCF always out to the left. Okay. And now we divide each term by what? The GCF. So 2x, 2x. 6 divided by 2 is what? 3. X squared divided by x to the first, 2 minus 1 is 1. So I get x to the first power plus 10 divided by 2, 5. X divided by x, 1. So my final answer, 2x times the quantity 3x plus 5. Now, we come over here and we do the same thing. GCF of the coefficients. Look at the 21 and the 35. Here's 21, here's 35. Does 21 go into 35? No. What are the factors of 21? 3 and 7. Quite simple. Factors of 35, it would be 5 and 7. So I have a 7 and 7. So I know my GCF is 7. Now I look at the variables, I only have one x. So I can't bring that over because it's not in both terms. So my GCF is 7. So what do we say to do? That's correct. Put parentheses, bring down blank parentheses, put your GCF outside, so that's a 7, okay? And now I divide by what? Divide each term by my GCF, okay? 21 divided by 7 is 3, so I get 3x. 35 divided by 7 is what? 5. Now when I come back, look at what I have. I really don't like this 7, so I'm going to sit there and erase this. And I'm going to make a nice little cute 7. There we go. So there's 7, nice and neat. All right. So how many terms do I have? I have 2 terms. And what do I see in each term? That is correct. I see a GCF of 3x plus 5. So if I know I have a GCF there, what am I supposed to do? Put it in parentheses. Bring down your parentheses. What goes outside to the left? Your GCF. 3x plus 5. So that says 3x plus 5 times an empty bracket. What do I do with my GCF? Divide each term by that GCF. Okay. So 3x plus 5 divided by 3x plus 5 is just 1. What's left? 2x. 3x plus 5 divided by 3x plus 5 is just 1. What's left? Plus 7. So I can rewrite this as what? 2x plus 7 here. What goes out there? 3x plus 5. And what can't I forget to do? That's right. I can't forget my 2. Because 3x plus 5 and 2x plus 7 replaced this set of parentheses, okay? So my final answer is 2 times 3x plus 5 times the quantity 2x plus 7. What was my original equation? Well, if I scroll all the way up here from these steps, I would see that it was 12x squared plus 62x plus 70. And that's how you factor that, okay? So my final answer is 2 times the quantity 3x plus 5 times the quantity 2x plus 7. Example number 2. Let's make sure we know how to simplify all these, and then I'll go to the next step, okay? So what do? We look at 3, we look at 11, we look at 6. Does 3 go into 11? No. Does 3 go into 6? Yes, but it needs to go in all 3. Is there anything with this 11 that can go into 3 or 6? Well, 11 is bigger than both, so I know it won't go in even. So guess what? There's nothing you can do to this one, and I wanted to make sure you saw that. I cannot simplify this quadratic. I have to leave it as 3x squared plus 11x plus 6. Example number 2, the 3x squared plus 11x plus 6. Well, we weren't able to simplify it, but what? I can still figure out what A, B, and C is. So A is equal to 3, B is equal to 11, C is equal to 6. This is positive, this is positive, this is positive, okay? So I'm able to use a chart on this also, but you need to know what A, B, and C are. All right, so here we go. Same thing for example number 2. I have an A. Absolute value of A is 3. Absolute value of C is 6. 3 times 6 is equal to what? 18. A lot easier to deal with, correct? All right, so here we go. I always start with 1. 1 times what? 18. 2 times what? That's right, 9. 3, 6. So 4 doesn't go in, 5 doesn't go in, and I'm back to 6. Done and done. Those are the factors that I am going to use in order to see if I can find new factors of 18. All right, example number 2. I literally sit there and do what? Okay, I know that C was what? Positive. B was what? Positive. So therefore, all of my factors are going to be what? Positive. Does that make sense? So I'm just going to add them up. Remember that I'm trying to get when B is equal to 11. Yes? 1 and 18 is 19. 2 and 9 is 11. 3 and 6 is what? 9. So which one works? 2 and a 9. That equals 11, so I'm good to go. Okay, so this is the step that is new because of what? A being greater than 1. All right? So remember, we had this as our equation. Nothing happened to it. We weren't able to take out a 3, 11, or a 6, correct? But we did take 3 times 6, and we got what? 18. And we know that 2 times 9 is equal to 18. We also know that 2 plus 9 is equal to 11, which is equal to what? B. And we need that to be true every single time that we do it, okay? So now, what are we going to do? We are going to rewrite this quadratic. So 3x squared. Nothing happens to the first term. But this 11x, I am now going to split into 2 different terms using the 2 and the 9. So I'm going to add 2x plus 9x. 2 plus 9 is 11. So it's 11x. All I did was split them into 2, and I keep the 6. Okay? Keep the 6. So now I have what? It was 3 terms, but now I have how many terms? 4 terms. And you need that so you can group in the next step. Okay? Okay, so the second example, what am I going to do? That's right, I'm going to factor by grouping. Okay, factor by grouping. I have my 4 terms. All I have to do is take the first 2 terms, put them in parentheses, take the second 2 terms, put them in parentheses, add them together so I don't change anything. I'm not going to multiply them. Add them together so I'm good there. So what do? I look at the 3, I look at the 2, find the GCF. Is there a GCF of 3 and 2? Nope. So I look at x and the x. I have an x squared and I have an x to the first. Which one's the smaller one? The 1. That means there's at least 1 in the other one. So my GCF is x. What do? Put it in parentheses, drop down, put a blank set of parentheses, put my GCF outside. And now what do? Divide each term by a set of, by my GCF, which is x. So 3 divided by 1 is just 3. X squared divided by x to the first, 2 minus 1 is x. Plus 2 divided by 1 is just 2. X divided by x is 1. So I get x times 3x plus 2. So now I come over here. I want to find the GCF of what? 9 and 6. Here's a 9, here's a 6. I know 6 doesn't go into 9, but we both know that 3 will go into all of it, right? So 3 is my greatest common factor there. And then I look at x. There's no x here, so I know that my GCF is just plain 3. So parentheses, parentheses, make my empty parentheses, put my GCF out front. Okay, so the 3. And now I divide by what? 3 to each term. 9 divided by 3 is what? 3. Bring down the x. 6 divided by 3 is what? 2. And look at what we have here. I have 2 terms. And do you see something that's same in each term? Yes. I see a GCF, a common factor, that is what? 3x plus 2. So we do the same thing. Put this in parentheses, this in parentheses. Drop down, put your set of parentheses. This way, I just do it this way because it's visual, okay? Makes my life easier. So put my GCF out front, 3x plus 2. That's my GCF. And now I do what with my GCF? That's correct. Always divide by your GCF. Okay? So when you're factoring, it's division. Okay? Factoring is division. So 3x divided by 3x, just 1. So what am I left with? X. 3x divided by 3x, 1. What's left? Plus 3. So I can rewrite this. 3x plus 2 times what? X plus 3. And do I have any numbers that I have left out? No. So my final answer is that. Now, my final answer is from the problem what? 3x squared plus 11x plus 6. That's where we started. We factored it all the way out, and we found that by factoring it all the way out, that we have 3x plus 2, x plus 3. So practice problem. I know you're sitting there after looking at this video like, oh my God, this problem is so long, it takes forever. Cool. Totally understand that. But if I put it all together and I'm not teaching it and I just do the problem, it really doesn't take that long. So for instance, if I have this, what do I do first? I look at 12, I look at negative 48, I look at 45. I know what? 3 goes into all of it. I'm just looking at it. A 5 wouldn't go in. This 5 really distracts everything, but 3 will go into all of it. So let's do it. I'm going to take this. I know that my GCF is 3. So I put here, I divide by 3. Okay, here's a 3, here's a 3, here's a 3. 12 divided by 3 is what? 4x squared minus, that's a 1, that's 18, so 6. So goes in once, 15, 15. Simply put, right there. Now, I have a quadratic. I immediately see that a is equal to what? 4. That is greater than 1, okay? So I know I'm going to have to do an extra step. B is equal to negative 16. C is equal to what? 15. So what do I do with that? I do the absolute value of A times C, right? So that is 4 times 15. What is 4 times 15? That's 20. 4 carry the 2, so 60. Factors of 60. Start with 1, 60. 2, 30. 4 would be 1, 20, so 15. 5 would be what? 1, 2, so 6. 6 is what? 10, 7 doesn't go in, 8 doesn't go in, 9 doesn't go in, there's 10. So I'm done there. Now, what is C? C is what? Positive. B is what? Negative. So immediately I already know that all of these are going to be negative. All you have to do is look at the graphic organizer. So when I go to add them, I'm looking for B is equal to what? Negative 16. Okay. So this was a 6 and a 10. Now, this is negative 61, negative 32. This was what? 3. Yeah, so 3 and 20. So negative 23, negative 17, negative 16. Which one worked for you? That's correct. This last one right here. So now I do what? I rewrite. So instead of writing a negative 16x, I'm going to split it. So keep the 3. So 3's out front. 4x squared. Split your negative 16x, right? So I'm going to use negative 6x, negative 10x, because right here, negative 6, negative 10, and then keep your plus 15. And now that I have that, what can I do? I can factor by grouping. So I have 4x squared minus 6x. Group those together. Add them to the negative 10x plus 15. So if I'm going to factor by grouping, I'm going to take 4 and 6 aside. What goes into both? 2. So my GCF is going to be 2. Then I look at x squared, and I'm going to look at x. Well, there's at least 1 in each term, correct? So remember, parentheses, parentheses. Then you want to sit there and do your empty parentheses, put your GCF outside, and divide each term by your GCF. 4 divided by 2 is what? 2. X squared divided by x, bring down the 1, minus, I get 6 divided by 2 is 3, x divided by x is 1. Now, I come over here, I do the GCF of what? That's right, 10 and 5. 10 and 15. What goes into both of them? 5. Biggest number that goes in. So I know that GCF is going to be 5. Here's an x. There's no x, so my GCF is 5. So now, here's the thing. If I only divide a 5 into here, you got to pay attention to this. I can pull out this negative 1, right? If I only divide a 5 here, I get negative 10 divided by 5 is negative 2. But this 2 is positive. So I'm going to make this a negative 5. Now watch what happens. Remember, parentheses, parentheses. I'm going to divide by a negative 5 because that's my GCF. Okay? Here we go. I got negative 10 divided by negative 5. That gives me a positive 2. X divided by nothing is just x. 15 divided by negative 5 is negative 3. See how we changed it? We just really pulled out a negative 1 out of this, and we're able to go. Okay? That's one little thing that you got to know as you go through. How many terms do I have? 2. What do you see in each term? Yes, a GCF of 2x minus 3. Remember, if one said 2x minus 3 and the other one said 2x plus 3, they are not GCFs. When you do grouping, they should come out exactly the same. So you might have to pull out a negative 1. Okay? So remember what I said. We put it in parentheses. Then we make our own set of parentheses. And we put our GCF out front to the left. Now what do? I divide by my GCF. 2x minus 3. Divide by 2x minus 3. When I divide these out, just like that, I get what's left? 2x minus 5. Now, here's where you do not forget your 3. Can't forget the 3. So it's 3, 2x minus 3, 2x minus 5. Okay, and this is your answer. Do not forget the 3 if you have pulled any number outside. Okay.